Okay, let's proceed with a concept called modular programming, which is an interesting concept in Python because you don't have to code everything. There's a lot of modules that people have or developers of Python have prepared for you. So you just have to call and use. So, for example, you want to use some mathematical functions. You don't really need to, program from the beginning. For example, you want to look for sine or for cosine or tangent or any trigonometrical problems. You just have to, call and then proceed. So we call this kind of programming as modular because you have modules that are ready for you. And I'm going to give you two examples. One example is mathematical module, and the other one is NumPy, which is also called numerical Python. You're going to meet NumPy a lot of times as you go along, especially in the coming courses. So I'm going to give you a hint of it, but for the details, you're going to meet with it as you move along. Math as well, you might need it, and there's a lot of us Python modules or Python kind of packages that you can use. So for the mathematical module, it has a lot of methods or functions in it. You have a number, let's say, or a variable, let's say x, which equals to say 5.6. And probably you just want to round it off. How do you do that? But before doing that, you need to call, you need to import, you need to bring it in on the board, the mathematical function. We use import. Most of the languages, I think Java uses import as well. I don't remember both C++ or C. Some languages do use include, but they all mean the same. You just have to import or include or whatever other language you might use. But for Python, we normally use import, right? So you have, let's say, this number, and you want to round it off, and you just simply say round that particular number, which is x, or you can put a direct variable, a direct value like 5.6. And now you can print it to the screen. So you can just go ahead and print it direct here by saying print, the round x. What will be the outcome? If we run that, you could see it's rounding off to 6, right? What if it was like, 5.4? What will be the outcome? It's rounding off to 5. So I think you can all remember, rounding off mathematics. But what if you want to go to the to get, let's say, the absolute value? So we use abs. So you can say absolute value of x. What will be what is it? Let me just print it direct like that. Print the absolute of x. I'm sure someone can guess what is output. It is 5.4. And if you can recall what an absolute value is, regardless of whether it's positive or minus, it has to be positive. That's the absolute value. So for example, if I change this one to minus 5.4, you can see if we say run, it changes the absolute value to 5.4, which is positive, as opposed to negative. And you can see the rounding off, it has rounded off to minus 5 as the nearest so this is the way you can work with mathematics. But there's a lot of other modules or functions in the math module. You can calculate a lot of other problems. And how do you call them? You can use the math dot, and then you call the particular function. For example, you wanna get the upper. Let me change this one to positive. The original example. You want to get the upper value, right? So you can say, for example, upper of that particular number. But here it's a little bit different. And sorry, what am I using? Sorry, let me use the word math dot. Now, if you're using PyCharm, if you write math dot, it will bring all the functions that are within mathematical module or math module. So if we want to get the upper value, we use cell as a ceiling, right, of works. What will be the output? Let me just print it straight. You can say print this value here, or someone could do a different trick. Okay, let me just print, and you will see the ceiling or the upper value of 5.6 is what? Is 6. Or even if it's 5.7, it is 6. What if it's 5.2? It is still 6, right? And what if you want to get the base? You can also print math dot. What do we use for the base of this? Because or the lower value, we call it a floor. So you can say floor of x, and once you run it, what you get, it's 5. Regardless of whether it was 5.6, you still get 5, right? I hope you're together. And you still can do a lot of more other things. For example, you want to use some pi. You remember pi is equal to 3.14 and stuff, right? Now we want to use pi, so you can say, well, you want to print math.pi, right? And that's it. Pi doesn't have these brackets, so it just pi as pi. And you run that one, you can see. So someone else could say, well, I want to print, I want to include a message and say, let me use formatted string. So let me say the value of pi is, I don't know if it will work, but I hope it does. Shouldn't give us problems. What will be the output? So the value of pi is 3.14 stuff, blah, 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 right? So someone else might want to go into the details and get probably the sign, for example. What is the sign of, let's say, 30? Sure, some of you could remember these values. So how do we get sign of 30? We say math dot sign, and then sign of what? Let's say of 30. What's output? We can print it out and say, well, print math dot sign of 30. What will be the output? Minus 98. I don't remember exactly what were the values. Let me try minus, value of sine 60. What will be the value of sine 90? And things like that. So you can play around with some mathematical problems using the mathy module. Now, for more math functions in this module, you can visit Google and search for Python math functions, and you get a lot of them, and you can go around and play around with them. So that's it for the math module. You can, as I said, you can play around with them, but also that's one way you can import math. But the other way, you might not want to import just a single module in a single statement. You can include a lot of other modules. For example, you can say import math and import random. You just put a comma and you're done, right? So for that particular case, for example, you want to play around with some random numbers, right? And for this case, you can if you want to play with random numbers, you can go straight to import random. But if you want to, multiple modules, then you can go around and say, wow, I want some random module, I want mathematical issues, and then you can work around. So random also uses, you call the name and then you specify the function you want to use in the random. For example, we have a module random and dot. As I said, if you're using PyCharm, you can get a lot of listed functions that are within random. But for this case, you need to memorize them. So let me say I want to get some random integers. So it's int. Random integers. Let's say I want random numbers between any random number between 0 and 10. So you can say 0 to 10, right? Using that particular approach. So let me just print them straight and say, okay, print something like that. I want to print any random number between 0 to 10. And I will run it. Well, the first number is 5. What if I run again? What will be another random number? 2. What if I run again? 6. What if I try to run again? 0, because it's 0 to 10. So, and everything is inclusive. 8. So you can play around and generate a different number because it's coming up with some random numbers. Or the other way, you could even say, oh, well, I want random numbers between a certain range, but it should be jumping at a particular interval. Let's say I want a random number between 0 to 10, but it should be after every 2 numbers. So you give the interval and as well as the you give the range as well as the interval that you want to be jumping. So let me say I want to get random numbers, but in a range. We say rand, but in a range of, let's say, between 0 up to 10, but I want to be jumping by probably 2. So means you get 0 itself, 2, 4, 6. You don't get 1 or 3 or 5 because you're jumping by the interval of 2. So if you try to run this, what you get? You're getting 8 in the first place. Let me comment out this. It might be confusing for some of you, but okay. Let me run again. I'm getting 2. I'm getting I'm getting 8, and I'm getting 8 again. I'm getting 8 again. This is crazy because I think it doesn't get. Let me change this to 20. What will be the output? Getting 2, getting 6, getting 14. So you see, you won't see any number that's it should be in the interval of 2, right? So you can play around with those kind of crazy stuff, but it should be easy. So you want to get some. There's a lot of Python modules that you can play around with them. These are just some of them. Now the other way to import a function, a module, you don't need to. For sometimes you don't need to import everything from, because there's a lot. For example, in the math function, you have a lot of in the math mode you have a lot of functions. For example, rounding, absolute, ceil, floor, pi, sine, cosine, and a lot of them. Now sometimes you don't need everything, because if you load everything into your the interpreter has to go through looking for every function in that module. Now sometimes you may want just just a single function. For example, you just want pi, or you just want cosine, or you just want any of those. So you don't import everything. You say from math as a module, import a particular function like this. For example, you from math import cosine, or import pi by putting comma. If you want to import anything else, you can just put comma and you import. Now from this case, for example, you want to print, let's say you want to print the sign of what? Remember, you don't write sign of 30. Remember, this is a function, so it should be in a bracket, sign of 30. Who can guess what could be the problem? You see, we have imported only cosine and pi. Let's see if we try to print sine from the math, right? What will be the output? If we run this, we are running into a problem. Why? Because name sign is not defined. It's nowhere to be seen. So if you change this, let me comment out this, because it gives us error, because it's not imported. So we can, if we try to print cosine of 30, we're going to get the answer because we imported the cosine from that math module. So if you run it, you see we are getting the value for cosine of 30. If you change to 45, you still get the result. I hope you're together, and it should be easy like that. Then let's see the NumPy. NumPy is a short for numerical Python, as I said, and NumPy has a lot of applications. Whenever you're dealing with data science, or whenever you're doing data science, you always use this. You will always use NumPy. There's a lot of other modules like pandas. You're gonna meet them, but sometimes it's specific to whatever you're doing. Those who are coming to teach you about machine vision in agriculture and stuff, or machine learning in general, they are going to use all these modules, a lot of these modules, NumPy, pandas, and all those stuffs. So you still also import them, right? So you can use import NumPy like this, and you can use the functions in NumPy. Now you need to learn about NumPy because I'm giving you the hint. You don't need to bother about it. But sometimes we don't really import NumPy like that. We can, for example, here we were calling math dot, but NumPy, you know, every time you want to use it, you have to say NumPy dot. So most cases, more often, we normally say import NumPy as. You give an alias. An alias is just like an AKA, right? Most people use NP. So whenever you want to use it, you could say, well, let's say I'm defining an array. And it's mostly used on arrays. And arrays, for example, an image is an array of pixels. Pixels are just arranged as you know, rows and columns. So whenever you're working with images, you're going to use NumPy because that's the best module for working with arrays. For example, I'm defining an array A, and I want to call a NumPy.array. So I can say, instead of saying NumPy.array, I can say NP.array, and I can define my array. Now, defining an array, we normally use a bracket, but remember, array is a function. So for this case, we put within that brackets, we put our corner, or I don't know, squared brackets, and maybe my array is just 1, 2, and 3. And what if we print that? So you can say, well, I want to print A. What will I get? Let me run and see. Wow, that's my array, right? But that's just this. I don't know, how do you call them? An array that's just one row. But you can have arrays that has, you know, 2 rows and 3 columns and something like that. So we can say, yeah, we have an array B that is NumPy, which is NP. Now we're giving it an alias, and say array, we give those brackets. But remember, because we have this big array, so we can put array like that. But remember, we have these 2 rows, so each row has its own array. So we can say 1, 2, 3, comma the second array, which is, let's say, from 4, 5, 6. What if I print this and print B? What will I get? Something like this. So you can play around with. Now this is just for demo. You know, this is almost useless. We are just printing it on the screen, right? And several other applications. For example, someone defines something like this. Let me show you. Let's say NumPy.diagonal. I want to get the diagonal values like this. Sorry. And let's say that this, I want to draw an array that the diagonal values are the ones I'm supplying here. Let's say I'm supplying 8, 9, 7, and 6, right? How will it look like? How will something like this actually look like? So we can guess what will be the output. Let me print out. Let me comment out this. I don't need them, right? Let me print. Boom. There we go. So you can see we didn't even say print, so it's straight like that. Didn't even say, but you can see these are arranged diagonally, and the rest are zeros. So you can have a big array like that, with everything is arranged in that way, right? So for more details about this NumPy and these other modules, you're gonna meet them as you move around, right? But you should be ready that whenever you're working with Python, sometimes you might need some predefined modules that come along with Python installation.